I'm going to talk about general computing, and I think one of the things that at Instabase, which we are trying to look at is like what kind of computer we need to build, which can basically power the next few decades of computing. And there have been a lot of articles which you find about Instabase, and I think most of them describe us completely wrong. So we don't do any of those things that you read. But before I get into any of these, let me just show you this short clip, which is really.
He wrote a book, though, before he got this job called The Business Value of Computers. And it's rather thick and it's not good bedtime reading, but you can plow through it and there's some incredible stuff in it. And he asked two questions in particular. One was he surveyed a bunch of companies from not very successful all the way up through really successful. And there's somebody taking notes here. And he asked how much they spent on information technology as a percentage of revenues. And he got a very counterintuitive answer, right? You'd think that either the really successful companies would either spend more or less than the not successful companies, depending on your theory. But it was exactly the same. They all spent about 2% of revenues on information technology. And he found this curious, and so he asked another question. How do they spend their money? And he found out that the really successful ones, or actually let's start with the not so successful ones, as success increases and dollars increase, he found out that the not so successful ones spent the majority of their money on management productivity, and the more successful ones spent the majority of their money on operational productivity applications, right? Now, this was not very pleasant for me to read because I spent the first 10 years of my life on management productivity, which was PCs, right? PCs and Macs never attacked operational productivity. They just attacked management productivity. Why is that? Because you can't go down to your local computer store and buy an app that will help you do stock trading, or will help you run a hospital, or will help you in whatever operational part of your business you want to automate, right? Unless you're a very, very small business, then you could run some accounting packages. But other than that, if you're a medium-sized or large business, these things never attacked operational productivity.
At the same time, this talk was in 1992 at MIT. There was a paper that came from Xerox PARC. This paper came in 1991. The paper title is The Computers for the 21st Century. At that time, I think the PC was the kind of general notion as the way people would use computing. And this paper basically said that PCs might not be the best way of how people use computers. And in fact, like at that time, it talks about these scratch pads and this basically shared whiteboards, and basically shows this picture of like how you will have this phone-sized computers and the iPad-sized computers and these file servers and other things that will be connected over the network, and you'll be able to do all the work. The basic ideas from that paper that basically came in was that the personal computing PC is a misplaced idea. And computer ideally should not be owned by people, but rather they should disappear in the environment. And we should just use computers without knowing that we are using computers. It's like when you use Uber, you don't use computers. You basically say, I'm using transport system and I'm calling it transport. And basically it says that computers basically will come in different sizes, and different sizes would be suitable for different kinds of tasks. Like phone-style computers would be suitable for tasks like calendars, diaries, personal identification and location. The pad-sized computer would be useful for notes, reading, editing. And the board-sized computers, which is your desktop-sized computers, would be useful for the work-style stuff, which is monitors, video screens, bulletin boards. And now you see some of those ideas, which was basically written in 1991 to be true. And one of the basically conclusions that this paper made was that personal computers will be superseded by tabs, pads, and boards, which are basically different sizes of the screens that people would use for consuming computers. And if you look at like how we consume computers today, and the way I would like to look at it is like broadly categorizing different kind of applications that we use. And I think there are like 3 different kinds of applications we use. One we call lifestyle applications, which we use over phones. One is the management productivity applications, which we use over phones and tablets. And the other one is operational productivity applications, which we use over desktops. And we have some clear winners in some of these areas. Like if you look at the phone and tablets, Apple and Google kind of like control the operating system for this kind of computing. the Android and iOS. But for operational productivity, the game is still open, and I think there is not clear winner. Earlier, people used mainframes with terminals. Then basically we went into servers and desktops, and now we are basically getting into this cloud with Amazon and Google Cloud and Microsoft. So what would be an operating system for operational productivity? And that is an open question. And we might think of like this could be one, which is Amazon Web Services, many of you already know. Or it could be this one, which is Microsoft Azure, provides a bunch of services. Or it could be this one, which is Google Cloud Services. I don't know if any of them yet are the right operating system for the operational productivity. And the reason that basically I think so is because just think about a very simple problem. Like Steve Jobs talks about, like, can you build a stock trading application or a loan processing system? And like if you use any of these services, you have to still think about where to put load balancer, where to put databases, where to put like all the services and other things. But I think like there should be a better way to build these applications and to distribute these applications than like the building blocks provided by these services. So let me just quickly show you like what we are trying to build in Instabase with a quick like demo of how to build a end-to-end loan processing system in like 5 minutes or so, and then we'll get into some of the other slides. So let's take this problem of basically loans, and the way Instabase works is basically everything gets organized into what we call a repository, which has drives, which is like mounted file system. The way you have on Windows or Mac, you can mount like different storage systems. Same way you can mount databases and all that, but most of the value comes from what we call apps. So let's build a very simple application for loan processing. And typically what loan processing is, if you look at the slide, is you get a bunch of these documents, like you have to do some loan verification, do some mathematical computation, and check whether the person is eligible for loan or not. That's pretty simple stuff, but it's very, very hard to build. People spend like more than a year of engineering cycle to build these kind of applications, and that should not be the case. So how to do that? So one of the apps that Instabase provides is called Flow. So let me just quickly build one. So we'll say like, hey, build a new application for processing loans. And we will do this in Data Driven NYC. We say flows. We say new flow. Let's call this FirstMark. And let's say like this particular flow handles all the data coming from maybe Intuit pay stub. So we said this is a flow. So this requires a bunch of steps. Maybe very first step could be process the files, where files could be PDF or images or Excel, Word, PowerPoint, whatever. In this case, we know these are going to be images or scanned documents. Now, if you look at the output, what basically this does is it took these documents and convert them into some text representation, which is like reading these images into some text. While this is good, this is not useful, because at the end you have to make a decision on things like what is gross pay, what is social security tax, those kind of details. So what you do is you basically add another step saying like, hey, I'm going to convert these into records where each record is an entire document, and then from these documents we're going to extract fields. So this basically kind of like tells the system what the records are. The extraction basically is based on, at the end, like from this we want things like what is check number, what is the name, what is social security tax, what is pay period. And the way Instabase does is you just simply say like these are the things you're looking for, and system will automatically figure out how to do this. So I say like, hey, I might need like name, I might need like check number, I might need like, let's say, pay period, I might need like pay date, I might need like maybe checking account number, or whatever you need. You just simply fill those things in. And what system does is, this technique is called program synthesis, where given input output spec, and system automatically figure out what is the right program that's needed to solve this problem. If you look at this just by giving this example, what system is trying to do is system automatically tried to figure out what is the right code that's needed to solve this, but not just the code, but also it showed like if that code was run on other documents of similar type, what output it would produce, so that you kind of like verify this. And you can save this as a program. So let's call this FirstMark and I'll save this inside Intuit prog, save, and then we add that as a step. And we say like, okay, next step is apply refiner, where the refiner program is this FirstMark, and then you say like, hey, this is all done, maybe like merge all the results. And that's it. Like basically now when you run this, what this step basically did is, now when you run this on the input, it will basically do all of these coming from whatever like intuit pay stuff ever when it comes in future. So I'm just running this on the data set. And now it can give you basically the results, which is basically all of these values. Now you want to make certain decisions, which is about credit and all of those kind of things. So how do you do that? So you can do that by basically quickly, once you've gotten to this step, what you can do is, now you can apply all the business computation here. So let me just quickly show that to you. So once you've gotten all of this data, this is again, I think Barack Obama's pay stub. So we got all of this stuff. Let's say now we want to make some credit decision. And let's say credit depends on how much salary you earn per hour. So let's say we want to do very similar math, simple math, which is divide gross pay by 40. This might be 40 hours salary. And then basically send to our credit system. So we say like, hey, get the number from, oops, person gross pay, and divide that by integer 40. Hopefully that will give you salary per hour. Maybe we want to round this to 2 digits so that it looks like proper currency. And now let's say like I want to do some credit check system. So let's say like I want to do get credit score. And that might take like the salary per hour, and so it gives some result. Now of course if I run this, it's expected that it will fail, right? Because there is no idea of like what this get credit score is. One of the good things about this Instabase system is it basically comes with inbuilt grammar where you can extend this with your own language. So you can now just simply say like, hey, I'm going to basically add this automatic execution of this get credit score. So let's say like I'm just adding this. So there is a grammar in registry, and we'll get into the more details about this later. We say get credit score, which should be executed by a function called get credit score, written in any language of your choice. So we say like get credit score, and let's say like it just returns, it takes a number A and returns A multiplied by 10. You can do more complex stuff inside this, but for simplicity I'll just leave it here. And maybe since it is a decimal point number, converting into float makes sense. So assuming that I've not made any mistake, what you do is basically, now you can extend this with your own these custom computations that you're looking at here. So it gave you some multiple of whatever. So once you have all of these things, now you can kind of like extend this with your own like validations and other like decision making, which is the way typically people do is once they get all of this data, then they will do all the normalization the way you saw. Then they will do all the validation, which says tell me if base currency equal to local currency, yes or no. Tell me if the foreign exchange rate matches the required criteria. All of these validations will give you some answer, yes, no, pass, fail, whatever. Typically the credit team would maintain a table they call the scenario table, which basically says, hey, if all of these validations comes as yes, 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 that means it's a good case. Otherwise it's a review case or a bad case. And then then they would define like if everything is good, should we automatically approve the loan or reject the loan or do more review? So what happens is when you run this, you will see like it executes all of those things. And of course, like it currently just prints echo approved rather than actually approving the loan. But you get this idea from here that instead of echo approved, now in this grammar basically you define like your own like approve loan function that does your call or whatever. So what you basically saw was like, and then once you have done all of these things, what you do is you kind of like compile this into a binary. So that way, like now you can give it to somebody else and they can execute this. So basically somebody else can build this. So this is basically your loan approval binary that can be given to anyone who can run this. Similarly, you can build system for like claims or hospitals. There are like 40 different applications of different kinds. Some are used by universities, some are used by hospitals, some are used by insurance or banks or whatever. I could not cover all of them. But the whole idea is how you can make building applications like one-day work for most of these large companies. So now let me just quickly go to the slide. Okay, so I'll just click since I'm running out of time. So let's quickly. The reason why it matters is basically it really affects how quickly you can develop and deploy applications. And like whether you can deploy one application per 6 months versus 30 applications per 6 months matter how fast you can move or how fast you can compete. Also, basically, it increases the number of developers who can contribute. Like whether you need highly specialized developers who would take 6 months to build something, or something that anybody can build, which means that you have more supply of like number of applications available, the quality of the applications goes up. Like if you look at any good platform, like Uber or Airbnb, it's not that they made life convenient, but they also increased the supply of things. Like with Airbnb, the supply of hotels or supply of basically places that you can find significantly increases, or with Uber, the supply of drivers significantly increases. So our goal is to build the best operating system for operational productivity. We have a variety of applications, 30 plus, and our goal is to open it up for third-party application developers to build applications soon. And this basically shows you very quickly what it looks like, because since I could not show the complete demo, like you can just run many of these applications and the binaries that you get from other people directly on your data set, which allows you like complete reusability of things. So yeah, you have a bunch of these applications. You can run it anywhere, which could be on your local host, on any cluster of machines, on Amazon or Google Cloud or whatever. So yeah, this presentation was work of many people at Instabase, so I was just presenting. So none of these are just entirely my work or anything. Thank you.
All right, we're just have time for a couple of questions. So just one question from me. So I know that's going to be hard to respond in a few seconds, but what happens behind the scenes, right? I mean, there has to be some like data cleaning and formatting and all the things, right? If you build a universal sort of building block for loan applications, then you have to integrate with all sorts of disparate data sources. How does that work?
So you have to provide the code building blocks. Like if you think about like if you had to re-architecture, if you were engineering architect of a company, and if you had to basically build this, what all building blocks would you need? So you might need image processing building block that basically extracts all of those things. Then you might need basically ability to magically extract those things. That's an amazingly hard problem. Mm-hmm. And we have something called program synthesis that basically allows you to do that. And then you need an ability to run mathematical computation. How do you run mathematical computation at scale? So it's pretty similar to Lambda function the way you saw, but it basically uses the Excel-like grammar, and then from there it basically invokes. The reason why we had to build all of those ourselves is because we had to run on-prem or we had to run everywhere, so we could not use any of the cloud stuff. But that also allowed us to kind of like rethink everything from scratch, which means that now we could take this, compile this into a single binary, and you can run anywhere. Portability is one of the most important things because that gives the distribution of stuff. Like for example, if a company creates something for US markets, now you can go in like 7 days, now they can sell to every financial institution in the US markets. And that is real incentive for any company to build on top of Instabase, is because like it allows them to basically scale very fast.
Very good. All right, time for one question.
A business question. I'm curious how you got started, because you cover so many possible use cases. When you launched, it must have been hard to get to critical mass and get enough people knowing and using it.
So I was a PhD student at MIT and dropped out from there to start this. And at that time, we were looking at a project called Data Hub. So this came from MIT Data Hub project. And the goal of the Data Hub project was to look at what is the real abstraction that we need to build that will make the application logically independent from data. What basically means is that can you find the right abstractions so that you can write applications totally independent without knowing where the data is stored, how it is stored, and then you can run them. So we were mainly looking at that time, the file system and the databases as the two kind of like the sort of the storage units on top which we can run. But what it gave us is sort of like the understanding of like what are the core building blocks that needed to be built. So at MIT, we basically sort of gave it to a bunch of people to play with it and got a lot of feedback. And that's why it allowed at Instabase making some of those abstraction choices much, much easier. From the business perspective, we didn't know so when we started the company, we had no idea where it would be used. So in fact, like we went to some data scientists first, and they were like, yeah, we'll pay you like $100K, that is valuable, but if you solve this problem, then that is worth like many millions of dollars to us. And then we were like, oh, it makes sense. Then we basically focused on some of those. And so, that's how kind of like the choices of what to focus on, what not to focus on came from the business perspective.
All right, very cool, very ambitious.
Thank you.
Thank you very much. Appreciate it.